Hello students, welcome to Organic Embers YouTube channel. In this video I am going to solve a question which is JEE Advanced level. The question is a little bit lengthy and you need to practice your fundamentals before you solve this question. You have to brush up your basic concepts like isomerism, the preparation and reactions of some of the organic molecules. Let's get started with the question. So there is a molecule P with the molecular formula C12H10O2 and it is optically active. Upon hydrogenation, it forms optically inactive molecule and you see there are 6 hydrogens added. The Q molecule upon oxidation using hot KMnO4, it is forming dicarboxylic acid. The same molecule upon halogenation forms say product R. This P molecule gives carbon dioxide with sodium bicarbonate. So this is the information given in the question. Now you are supposed to choose the correct statement or statements for the above series of reactions from the options. Whenever a molecule with a molecular formula is given, the first better thing to do is calculate degree of unsaturation. Degree of unsaturation will tell you how many double bonds or how many rings or is there a possibility of triple bond for the given molecule. The formula is 2C plus 2 minus H by 2. For oxygen, we don't consider any number here. Oxygen means plus 0. You think like that, okay? 2C, the number of carbons are 12. So plus 2 minus, how many hydrogens we have? 10 divided by 2. Upon solving this, you will get 8. That means what? There can be either 8 double bonds or 8 rings or combination of a double bond and ring and a triple bond also. But look at this, the product, the final product, it shows aromaticity. That means the molecule is aromatic, means our molecule must have benzene ring in it. The degree of unsaturation for benzene is 4. So out of 8, 4 corresponds to benzene ring. So we need to account for the rest of the 4 degree of unsaturation. Now, P gives carbon dioxide with sodium bicarbonate. What does that mean? That means this essentially have a carboxylic acid. Whenever we have a carboxylic acid, it reacts with sodium bicarbonate to form carbon dioxide gas. And this carboxylic acid will have one double bond. That means what? This molecule has degree of unsaturation 5. So now we need to give accountability for 3. That means what? There can be 3 double bonds or 1 triple bond and 1 double bond, because whenever we have triple bond it accounts for 2. So 2 plus 1, 3. So that possibility is also there. Alright. Now moving on. When you have this P molecule, upon hydrogenation, it is forming C12H16. That means it corresponds to 6 hydrogens. As I was telling earlier, it might have 3 double bonds or it might have 1 triple bond and 2 double bonds. 1 double bond, okay? Because 1 triple bond corresponds to 2 degree of unsaturation, right? Now, this upon hydrogenation forming optically inactive means there has to be a carbon which is attached to same number of carbons. So that is one possibility. Now for more information, what we can do, we can go through the options given here. The total monochloro products obtained by chlorination of compound Q gives 7 isomers. We don't know this because we don't even know the structure of Q. Moving on to option B. The IUPAC name of P. Okay, they have given some name. Can we consider that as our molecule P and try to do the series of reaction, because there can be more than one right answer here. Now the IUPAC nomenclature is also not direct, okay, it's not simple, it's a little bit complicated. I'll tell you how to do the conversion of IUPAC name to the structure. Whenever you convert the name to structure, always start from the end, that is benzene carboxylic acid. What is benzene carboxylic acid? Benzene carboxylic acid is benzoic acid, like this, CO4H. Okay, and now this part is done. Now look at this. The third position from the ipsocarbon, 1, 2, 3. This is where a substituent is there. What is the substituent? Again start from here. Prop 2 enyl. So prop means 1, 2, 3. 1, 2, 3. 3 carbons are there. And the numbering should start from here. 1 dash, 2 dash, 3 dash. That means what? At second position there is a double bond. This is propene, right? And it is present as a substituent, therefore propenyl. Now on the first position of it, like 1 dash, it's supposed to be 1 dash, 2 dash. If it's not given also, it's understood, okay? 1 ethynyl. That means on this carbon ethine must be there and it is present as a substituent. That's why ethynyl, okay? Can this be our product P? That is the question. In order to verify that, let's take the help of degree of unsaturation. This part is done. Now we have to correspond it for 3. That means, as I was telling earlier, there has to be 1 triple bond and 1 double bond. Yeah, it can be the molecule, because when you do the series of reaction, it should match now. That is the only thing you can do now. Okay. When I do hydrogenation in presence of palladium, how many moles of hydrogen being it is consumed? 3 moles. That means 2 moles here, 1 mole here. Let's do the hydrogenation also. Hydrogenation of this. This is much simpler this way, right? Complete saturation. Here also 2 carbons are there, complete saturation. Now this must be product Q. Now let's see what they are saying for product Q. Q, they're saying it's optically inactive. Can it be optically inactive? Yeah, this is optically inactive, whereas this is optically active. Let's verify that also. This carbon here, it is attached to hydrogen. There is a ethyl, right? Here there is a ethynyl, right? Ethynyl and ethynyl. So all the 4 groups are different. Yeah, there is a chiral carbon here, which changed to optically inactive due to the chirality is gone now because you're doing hydrogenation. So product Q. This is also correct, right? So now moving on. The hot KMNO4, yes. Whenever you have alkyl group here, right? If there is 1 hydrogen also here, right? 1 benzylic hydrogen also, it is enough to convert it to a carboxylic acid. Yeah, this is also correct. So far everything is correct. So that means what? P structure is correct, right? And Q gives effervescence. This is also correct because still this is intact. Yeah, this is also correct. Now this is inactive, that's correct, but 1 monochloro product of Q is a chiral. That means what? You have to do halogenation. That is 1 part left here. That means you take the Q and do the halogenation. So in order to do this, so now that we have verified B and C, let's start the next part for the halogenation of Q. Now let's rewrite everything, otherwise you will not know whether A and D are also correct or wrong. For this, you write the Q molecule, you replace hydrogens from the alkyl group, right? Depending on the types of hydrogen, the products obtained will be different. Say they are saying it will form total isomers of 7. Okay, so that means it's going to take lots of time, but no problem. You can practice once you get used to solving such questions in the exam, you can easily get the answer. Now what is Q? This is Q, right? So now do the chlorination. Whenever you do chlorination in presence of sunlight, don't forget this, okay? That means only this part is going to react. The chlorination will not happen on the benzene ring, because for that you need FeCl3, okay? So this is just in presence of sunlight, so it's a free radical substitution reaction. First you can remove hydrogen from here, you get chlorine, right? And then in the exam you don't have to write each and every molecule, okay? You can just try here, 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 like that, okay? So you can write one more chlorine here. Now you have to keep changing the position of the chlorine. Since the molecule is symmetrical here, you don't have to write here, okay? Again, it's one are the same. So you are going to get one more chlorine here. Okay, so you got one chlorine here, one here, one here. If you remove from here, it's nothing but this molecule. If you remove from here, it's nothing but this molecule. So don't do that again, okay? Now, one monochloro product of Q is achiral. Yeah, this is achiral, because there is no chiral carbon here. It was there earlier, right, before hydrogenation, but now no, right? What about here? Yeah, there is chiral carbon here, there is a chiral carbon here. So the molecule which is achiral, right, that is this one. So option D is also correct, okay? So let's check for option A. The total monochloro products obtained by chlorine in presence of sunlight, it includes stereoisomers as 7, okay? For this, see, this molecule is achiral, so it won't form any other molecule, right? Now let's check for this. Look at this. You have two chiral carbons here, so 2 to the power 2 would be 4, right? And what about this molecule? This will be, here we have a chiral carbon, so 2 to the power 1, that is nothing but 2, right? So this will be 4 plus 2, and this one 7, all put together, all including stereoisomers. How many monochloro products? 7. Let me repeat this part. This molecule, although it doesn't have any chiral carbon, they are asking stereoisomers, including stereoisomers, how many are possible? Yeah, this is one possibility. What about here? Because there are two chiral carbons here, here and here, 2 to the power 2, that would be 4. What about here? There is only one chiral carbon, so 2 to the power 1, so that would be 2. 4 plus 2 plus 1, so how many isomers including stereoisomers? 7. Yeah, this is also correct. So all the options given for the series of reactions, they are true. So how did we break down this? First you have to calculate degree of unsaturation, then it will give you a hint that it can be having a triple bond and a double bond. You use that concept for hydrogenation, right? And then try to predict the structure of the molecule, and it matches with what is given in the option. Then you verify, like with hot KMnO4, will it give the same product? Yeah, right? For chlorination, how many isomers you got first? So including stereoisomers, how many you got, that you have to verify, and that will give you all 4 options correct. Thank you for watching this video.